Okay, the founder effect occurs when a few individuals become isolated from a larger population. Now, again, classic example is that of the little finches getting blown from the mainland out to the Galapagos Islands. Or a small group of people get shipwrecked. Okay, if you watch the series Lost, that could be an example of a founder effect. A few individuals get isolated from the larger population. Allele frequencies in that small founder population can be different from those in the larger parent population. It may not reflect the allele frequencies in the population they came from. The bottleneck effect is a sudden reduction in population size due to some change in the environment. Again, nothing to do with the quality of the alleles for that particular environment. Some random thing, or in these days it's often human-caused thing, reduces the population size. The resulting gene pool may no longer be reflective of that original population's gene pool. If the population remains small, it can then may be further affected by genetic drift, by small random events happening that may further shift the allele frequencies. And the illustration in your book literally shows you, where the term bottlenecking came from. You have an original population, something happens that the only survivors of an event are a small sample, and in this case, when you look at the surviving population, you can see that things like the little tan beads are no longer represented. That allele frequency is now 0. And now the blue bead or blue allele is now the dominant allele in the population. Some random event might cause something to happen to that white bead, at which point now you have a fixed allele. The only allele present in that population is that of the blue allele. All the others are gone. And again, nothing to do with how the quality of those alleles, it just was an event that happened to take out the other individuals. And if you look at how we affect other species, understanding the bottleneck effect can help us understand why some species have had some there's been events that have modified certain species because of our activity. And the example they give you in the book is that of the greater prairie chicken. Loss of prairie habitat, the grassland habitat where these birds live, caused a severe reduction in the population of this bird in Illinois. The surviving birds had low levels of genetic variation, and there were some harmful alleles present in that small surviving population, evidence of which is only 50% of the eggs were hatching. So there were obviously some non-beneficial, actually harmful alleles in that tiny population left. And they give you illustration here showing the original range to the left and then the post-bottleneck range to the right. And if you look at the table in this illustration, for museum specimens, they were able to see what the number of alleles per locus, in other words, the variations that were present per locus, per location on a chromosome in this species, before the bottleneck event was fairly high, 5.2 alleles per locus. You look at the number underneath representing the modern era, well, let's say 1993, and you can see that genetic variation was much lower. And continue looking to the right, you can see how the percentage of eggs hatched changed with the loss of allele variety. And they also give you some other populations to show you what other populations of this bird look like in other locations. Okay, just closer view of these pictures. And as I just said, researchers use DNA from museum specimens to compare the genetic variation in the population before and after. So you can do is get things like the skins and tissues that are stored in museums and get little samples and be able to extract the DNA from those. In any case, the results showed a loss of alleles at several loci. The good thing is that sometimes we can help clean up the mess, and researchers introduced birds from other populations and introducing new alleles and bringing that egg hatch rate up to 90%, so up to a much more normal value. So, quick summary of genetic drift. Genetic drift is significant in small populations, so random events have more of an impact on a small population than a large one. Again, think of that lab we did. The first exercise were with large populations, 72 pairs. Then that second exercise, much smaller populations, and you many of you saw rather wide changes in allele frequencies because you were dealing with such smaller populations. So genetic drift can cause allele frequencies to change at random, again, more significant effects on smaller populations. It can also lead to a loss of genetic variation within populations. Again, look at that illustration with the bottle in it. And genetic drift can cause harmful alleles to become fixed. So they're probably heading that way, if not already there, with those prairie chickens, that there are harmful alleles that were just the primary allele, or the only allele in that population.